Welcome to the evolution of carnivorous plants. We start at level 0, where things seem quite ordinary. At the very beginning of this scale, carnivorous plants do not look dangerous at all to the eye. They often seem small, soft, and almost ordinary, especially when compared to the more dramatic traps seen later. What matters here is not power, but the first step toward a very unusual and unique survival strategy. These plants usually grow in poor soils, where key nutrients like nitrogen are very hard to find naturally. Over time, that environmental pressure pushed them toward a different path, one that would turn them into hunters. In this level, the plant is defined more by limitation than by any immediate threat to surrounding insects. It still depends mostly on sunlight, water, and basic absorption through its roots to sustain its daily growth. But the environment around it is already shaping something more specialized for the future of the species. That is why level 0 matters. It shows the origin of carnivory as a gradual response to hardship. Before there were traps, digestion, or prey, there was simply a plant trying to survive against the odds. Level 1. At this stage, the plant begins to show subtle signs that it is no longer ordinary. Its leaves may look slightly unusual, with shapes that hint at a different function beyond simple photosynthesis. There is still nothing obviously dangerous, but something feels off about the way the leaves are structured. These early changes are often tied to the plant's surface, where small adaptations start to appear clearly. What makes level 1 important is the shift in purpose. The plant is no longer just surviving passively. It is starting to influence its surroundings. Some species develop textures or secretions that attract tiny insects. The process is slow and almost invisible, but it marks a turning point in the plant's evolutionary history. Level 2. At this point, the plant moves beyond subtle trapping and develops structures to capture prey. The change is no longer limited to sticky surfaces. Its leaves start taking on specialized and complex forms. Turning into real trapping devices instead of ordinary plant tissue, this stage makes carnivory very obvious to see. A good example of this is the Venus Flytrap, one of the clearest symbols of carnivorous plant evolution.
Inside each trap are tiny trigger hairs. When an insect touches them, the trap snaps shut very quickly.
That movement is fast enough to surprise prey, but controlled enough to avoid wasting energy on false alarms. Once the insect is trapped, the plant begins sealing the trap more tightly and starts digestion from inside. What makes this level important is not just speed, but the fact that the plant reacts with precision. The plant is now an active predator, using mechanical movement to secure its necessary nutrients from the environment. Level 3. At this stage, the plant no longer depends on quick movement or light trapping mechanisms. Instead, it develops a more stable and efficient system. The structure forms deeper cavities or specialized tubes. These act as passive traps, designed to guide insects inward, making escape increasingly difficult once they enter. The process feels less like a reaction and more like a controlled environment built specifically for capture. This is where the plant starts behaving like a system rather than a simple organism in the wild. Everything about its form begins to serve a single purpose: holding and processing prey for its own survival. A good example is the Sarracenia, a pitcher plant that uses gravity and structure to trap various insects. Its tall, tube-like leaves create a deep chamber filled with digestive fluid at the very bottom. Insects are attracted to the rim by nectar, but the surface is slippery and very hard to grip. Level 4. At this stage, the plant becomes more visually aggressive and structurally complex in its design. Making its predatory nature impossible to ignore, the traps are no longer simple or subtle in appearance. Their shapes begin to look more exaggerated and specialized, with open cavities and curved edges for capture. The plant starts to feel less like something passive and more like a carefully designed and lethal trap. This is also where appearance begins to play a larger role, using color and form to attract prey. What once looked like a plant now begins to resemble something closer to a living, breathing trap. A good example is the Nepenthes, a tropical pitcher plant known for its large and hanging traps. Each trap forms a deep container filled with fluid, often suspended from long tendrils in the jungle. The rim produces nectar and has a slick surface that becomes even more dangerous when it is wet. Level 5. At this stage, the plant becomes more compact and more aggressive in its overall appearance. Instead of relying on large open structures, it develops tighter, more enclosed traps that feel very controlled. The visual design becomes sharper, with edges that resemble teeth and openings that look like hungry jaws. This creates a stronger impression of danger, even when the plant itself is not very large in size. Everything about its structure suggests that once something is caught, it is very unlikely to ever escape. The plant now looks less like vegetation and more like a small, self-contained predator in its habitat. A good example is the Cephalotus follicularis, often called the Albany pitcher plant by many botanists. Its traps are small but highly specialized, with a wide opening lined by rigid, tooth-like structures. These teeth help prevent prey from climbing back out once they fall inside the digestive chamber. Level 6. At this stage, the scale and capacity of the plant begin to increase significantly. Allowing it to interact with larger forms of prey, what once worked for insects now affects animals. Especially in environments where such encounters are possible, the plant is no longer limited to tiny prey. Its role in the ecosystem becomes more significant as it transitions into a true predator of vertebrates. This is where the idea of a plant as a true predator becomes much easier to accept. It is not just feeding on insects anymore. It is capable of something much more substantial and impressive. A good example is Nepenthes raja, one of the largest pitcher plants known to science today. Its traps can grow large enough to hold a substantial volume of liquid and support heavier prey. Small vertebrates such as rodents or amphibians can occasionally fall inside and become trapped forever. Level 7. At the final stage of this scale, the plant represents the most extreme form. Where size, structure, and efficiency reach their peak, the plant functions as a true apex predator. Instead of relying on speed, it depends on depth, strength, and the ability to retain large prey. The trap becomes large enough to handle complex organisms, reflecting a system that is fully optimized. Everything about its design is focused on scale and control, rather than simple reaction to touch. A strong example is Nepenthes attenboroughii, one of the largest pitcher plants ever discovered in the wild. Its massive traps can hold significant amounts of liquid and are capable of capturing small vertebrates easily. Animals such as rodents or amphibians can fall inside and become trapped due to the slick walls. Once inside, escape becomes nearly impossible, and digestion begins slowly over time within the pitcher. This plant does not chase or attack, but its structure alone is enough to make it effective. It represents the upper boundary of what carnivorous plants can realistically achieve in their natural evolution. The journey from a simple seedling to an apex predator shows the incredible power of adaptation. Thanks for watching this exploration of nature's hunters. We hope you enjoyed learning about these amazing plants. If you made it this far, you already know what to do. Like and subscribe for more.